I can hear you,
Hello.
Ruchit. You can go ahead.
Okay. Yeah. So extremely sorry for this delay. I'm starting this presentation. So I'm Ruchit Thakur. So I take care of the critical environments business in India for Cetra Systems. And I have with me, Priyank must have introduced. Priyank is the marketing manager for India, and Vivek Dikshit is the country manager who takes care of the entire business of Cetra in the Southeast Asia and India. So, this basically this webinar is for what is the importance of creating a safe air for hospital and healthcare facilities when we come to India. So, thank you, everyone for joining this particular webinar. Uh, we'll start with a small introduction of what Cetra basically is. Cetra was founded in 1967. So, and we've globally formed a part of Fortive Corporation, which is a Fortive Future 50 company, and we are headquartered in Boxborough, USA. So we have all our manufacturing facilities and headquarters in Boxborough, USA. Right. So just to give you the overview and the agenda of today. The agenda of today is what is safe air, what is the environmental conditions to be monitored in hospitals, how they have to be measured, and what all things are to be taken care of while designing a hospitals and healthcare facilities well in India, and what is the importance of particularly measuring the parameters like maybe pressure, temperature, humidity, and all other things, and what are the standards and accreditation to be complied, because a lot of hospitals in India, we intend to focus towards complying to the NABH and the ASHRAE standards globally, right? And then we will see some of the used cases wherein where in the hospitals and which areas in the hospitals are to be covered under this. And lastly, we'll see what are the Cetra solutions that can cover all these particular standards and the guidelines, and we can make the healthcare facilities the best, the world class facilities in India. So why is it starting with the importance of safe. Why is it important? Why is it important to keep air safe or clean inside the hospitals? Because we want to prevent the spread of the infection inside the hospitals. So basically, there is a lot of infection which gets spread it inside the hospitals as well, and it spreads from patients to patients, or maybe patients to the guests who come from. It spreads from different staffs and all other things. So we need to prevent that spread of infection within the hospitals. So that is one point why we want to keep this air safe inside the hospital. Second thing is we want to improve the patient outcomes, right? Because the patient can really recover really fast when the condition inside the hospitals is maintained well, right? And third and the most important thing is the safety of the doctors, the nurses, the caregivers, and the guests who come to visit the hospitals. So that is why hospitals have to be under a precise and safe environment. So that is one thing which we need to why we need to keep the air safe. But how do we keep it? So what are the things that have to be kept inside the mind while designing the hospitals? One thing is, do you monitor pressure or not? Do you monitor temperature or not? So monitoring is of utmost importance. So when it comes to monitoring, we have pressure monitoring, we have temperature monitoring, humidity, air changes, ventilation, what is the pressurization inside the OT, in the corridors, basically the isolation room, what is the type of filtration used in the AHUs. So all other things have to be kept in mind while designing the hospitals. So that is how you can create a better environment inside the hospitals, which is suitable for all sort of patients, guests, and doctors, right? So what do we consider as critical environment? So basically all the areas inside the healthcare facilities, like maybe the isolation rooms, the intensive care units, the operating rooms, the surgery rooms, the sterile preparation area, autopsy rooms, all other thing all these rooms come under the critical environment, right? So why we call it as a critical environment? Because these are the environments which are really critical for the patients and for the doctors because it is basically all related to the life care. So that is why we call it as a critical environments. So now this is the most important slide when we go to why the critical environments and what are the standards to be followed while maintaining the environments on under the hospitals. So generally globally, we will follow ASHRAE guidelines. The ASHRAE guideline will say you all about what is the class of the rooms to be followed, what is the temperature, what is the humidity. In India, we will follow NABH guidelines. So NABH guidelines and also follow this ISO 14644, which is a clean room standard, and it will give you basically what kind of the environment has to be maintained inside the operation theaters, inside the isolation areas, sterile preparation areas, everything. So generally India will follow NABH guidelines, right? So what are the NABH guidelines? What does NABH guidelines say? So basically it will say that if it is a minor OT or if it is a major OT. So if it is a minor OT, these all are the parameters that are to be monitored and are to be maintained. Similarly for the major OTs. So what are the parameters? For an example, if it is a temperature, so the temperature has to be kept around 21 degrees plus or minus 3 degrees. Similarly, what is the humidity? What is the ideal humidity? So ideal humidity is considered to be 55%. So there some tolerance or some variation is allowed, but the ideal humidity should be 55%. Similarly, what is air change, right? So air change again becomes very important when it comes to the safety of the patients. So what is air change? So air change is how many times the air inside the room changes per hour. So generally you will say that I should have 10 air change, 15 air change, 20 air change. So depending upon the guideline, so there are different rooms where different air changes are allowed. So there has to be like for an example 20 air changes with fresh 4 air changes per hour. So these are the basic parameters like air change, differential pressure, indoor air quality, air particle count, temperature, humidity. Those are to be maintained, and these are very strictly strictly written in the NABH guidelines. But we are not sure whether it is followed or not. So we are really intending towards the Indian hospitals to follow these guidelines and to monitor the space. So how do we monitor the space? We basically keep the monitors. We have the BMS system, we have the environmental monitoring systems, and we also have a local monitor. So that is how we measure the system. For an example, if it is a differential pressure, so when it comes to operating theaters, differential pressure becomes very important because there has to be no dirt or no contaminated air which should flow inside the operating theater. So the operating theater has to be under positive pressure. Similarly, if there are isolation rooms where you keep TB patients or COVID patients, so air from the room should not flow outside, which can contaminate the uh, general area inside the hospital. So the isolation room has to be under the negative pressure. So that is how these are all the parameters which are written in the NABH guidelines and are to be strictly followed while designing the hospitals. Right. So we have a small poll here on what kind of parameters do you think is to be monitored, or what do you think it is there in your hospital or not? So let us I would request everybody to answer this poll. Okay, 5 more seconds before. Okay, fine. So I think it's an amazing response. We have 91% people saying that humidity is maintained, 89% saying temperature is maintained. We have 72% people saying room pressure is monitored, and 65% saying air change, and 52 is particle count. So the least response what we have got is particle count and air change, right? So I think all of you are the amazing audience. So we'll go to the next slide. We'll see what all are the other things to be taken care of. Right. So we'll see what is what is air changes per hour. So we are starting with the least voted item, which is an commonly known as ACH, air changes per hour, which is again of very much importance when the HVAC system is being designed. So you see we have taken an example of an isolation room. So in isolation room, how do we create an isolation room? So isolation room is a room where the pressure inside the room is negative as compared to the pressure outside the room. So basically the outside of the room is maybe the hallway or the corridor or maybe some reference anti-room. So if you see in the diagram, we have taken the inflow of 700 CFM and the outflow is 800 CFM, right? So basically this will generate 100 CFM of negative difference inside the room. So the same way, if the HVAC runs in a similar manner, it will keep the room negative, right? So how do we calculate air changes per hour? It is calculated basic depending upon the dimension of the room. The length, width and the height of the room are required, and then we'll derive at the air changes. So what is air change? So basically if there are 10 air changes per hour, that means that entire volume of the air will change in every 6 minutes. So considering the ongoing scenario of COVID, so COVID is the best example to take with. Let's say you have an infected air, you have, let's say, 5 patients inside the room, so they're all COVID positive. So the air inside the room will be totally contaminated with the COVID viruses. So how do we know? How do we ensure that there are the COVID viruses keeps on reducing? So that is how we create a negative pressure and we increase the air changes per hour. So with this 10 air changes means the entire area will be entire area will become fresher within 6 minutes. So the COVID virus will be keep on moving out of the room. So that is how the air changes is calculated, right? So this is the basics of what is a positive and a negative pressure, right? So we talked about positive pressure should be there in the OT and negative pressure should be there in the isolation room. So how do we take care of this? For an example, this is in hospital OT. Now as per the NABH guideline which we talked about earlier, so what does the NABH guideline says? It says that the hospital operation theater has to be minimum under 2.5 pascal of positive pressure up to 5 pascal and 10 pascals. So how do we keep it positive? So the inflow is, let's say, 1200 CFM, the outflow is 1000 CFM, right? So the outflow is less than the inflow. So the air inside the room will keep on increasing. So this particular room will be kept under positive pressure as compared to this negative room. Sorry, the entire room, right? So the moment the door opens, the air inside the OT will flow outside because it is positive pressure, right? Similarly, the empty room is kept positive as compared to the reference pressure, so it becomes a dual security. So basically if this door is going to open, the air inside the entire room will flow outside. So in a lot of cases what people do is people interlock these doors. So for an example, if the pressure is not maintained, this door will not open, and if this door is open, this door will not open. So for an example, if the door between the anti and the reference is open, the door between the OT and the anti will not open. So that is how interlocking is done to make sure that the OT is 100% secure. Similarly, when we go to the isolation room, it has to be typically under 2.5 negative, or it can go up to 5 and 10 pascals negative also. So what will happen when this is a negative room? If this door opens, the air from outside will flow inside, because you don't want the contaminated air inside the isolation room, because there are patients suffering from TB, measles, or maybe COVID, all the infectious and contagious diseases, so they should not flow outside. So we need to keep these rooms as a totally negative isolation room, and the moment the door opens, the air from outside will flow inside. right? So any if you have any questions, any doubts, so you can just maybe just write in the chat box. We'll take the questions later, and let's make this very much interactive. Just keep on typing the questions, we'll answer it later. So right, we talked about air change, we talked about differential pressure. Right now we want to talk about what is temperature and humidity. So everybody has answered that 90 or 95% people know that temperature and humidity are going to be measured inside the maybe hospitals and the isolation room, the surgery areas, or maybe the sterile preparation areas where the surgery equipments are kept. So what is the ideal humidity and temperature to be maintained? So we'll say that 50% plus or minus 5% RH is acceptable. Similarly, any temperature between 19 to 25 degrees is acceptable under the classified area. Right. So these are the temperature and the humidity to be measured, and if these are not measured, it is our duty to give the feedback to the BMS system, wherein the BMS system will have maybe the dehumidifiers or the chill water line, hot water line, and it can be modulated accordingly to maintain this humidity and temperature. Right. So maybe most of the people here are aware of what is temperature and humidity. So now we go to particle count. So as per the ISO 14644 guideline, it also talks about the sizing of the particles inside the operation theaters and inside the critical surgery areas and the post surgery areas. So what does the guideline say? It will say that if it is a surgery area or if it is an operation theater, you should not have particles, any size of particles which should be greater than, let's say, zero point 0.3 or zero point 0.5 micron. So generally the operation theaters will fall under these ISO 4 and ISO 5 classes, which will say that the maximum allowable particle size of zero point 0.5 micron is 352, and in ISO class 5 it is 3500. So how do you calculate the particle counts? So generally there are HEPA filters which are kept inside the supply duct of the OT rooms. But whether it is functioning or not, how do you know that? So you have particle counters, right? So with the particle counters, you need to calculate the size of the particle before carrying out any surgery. So whether there are doctors here as an audience, or maybe if there are designers, it is our duty, being a system integrator or being a contractor, being a consultant, it is our duty to guide the hospital management about this particular requirement. Right. So these are the ISO classes which are to be maintained before carrying out any surgery. Right. So this will again prevent people or the patients from getting infected with the contaminated air. Right. So these are certain international standards. These are certain classified areas in as a critical spaces as per the international standards. And right. And for an example, if it is an operating theater, an isolation room, anti-room, protective equipments, compounding pharmacy, sterile preparation area. So you have it has to be in the positive or it has to be negative. What is the pressure to be maintained? Constant monitoring is required or not, temperature should be this much, humidity should be this much. So all these guidelines are there in ASHRAE and NABH as well. So it is our duty to be to make sure this is followed, because we want the hospitals in India to be at par with the hospitals globally, right? So these are certain examples of critical spaces, and these are certain examples of the non-critical spaces. So this is not the exhaustive list, but we have kept some of the areas like bronchoscopy, dirty linen, clean linen. So these are the areas which are under the non-critical spaces. So we have a small poll here. Priyank, if you can just activate the poll. Okay, 5 more seconds to go. Great. I think 35% of people have answered 0 to 10. So I think and 23% is 11 to 15. 25% have answered none. So when it comes to hospital, basically you need to very much mindful about the that what are the critical spaces inside your hospital or the hospital you are designing. It is our it is our duty to find out that what are the critical spaces, what are the parameters that are to be monitored, right? So we talked a lot about the guidelines, what are the spaces to be monitored, what are the parameters to be monitored, measured. Now we talk about how do we measure it. So we have got certain environmental monitors which will measure multiple parameters. We call it a Cetraflex. It has pressure, temperature, humidity, air change. So all the third party parameters which you can monitor here. We have got pressure monitors. We'll take you in the details. We talked about particle counts. We have got particle counters which are very much necessary to count the particles inside the OT and the surgery rooms. So we have got certain wireless transmission parameters for the retrofit jobs. We have got temperature, humidity sensors. Then we have got DPTs, differential pressure transmitters. We have got a machine called Cetra AirWatch, which is a beautiful product which we launched during COVID. And we have an environmental monitoring software which will monitor all the third-party devices and the parameters, right? I will start with a small video on what is differential pressure measurement inside the room. I'll start with the So we saw, what Cetralite is. Basically, Cetralite is a room pressure monitor. It will, monitor the difference of the pressure between the rooms. So, as we saw earlier that, how important it is to measure the difference of pressure between the OT, surgery rooms, isolation areas. So, Cetralite is a monitor which will give you a local alarm indication. So generally, currently what we do is we measure the difference of pressure right now, and then we send it to BMS. But we are not aware whether the pressure is maintained or not, because HVAC is a very subjective thing. You whether the filters are choked up, whether the door is open or not, you never know. So how do we check the pressure? So this is a device which will give a local alarm indication. So it will check the pressure and it will give you immediately an alarm if the pressure is not maintained. For an example, if you have set it at negative and the pressure is going positive, it will immediately give you an alarm. It will give you so maybe the doctors, the nurses, the ward boys, basically the healthcare and the hospital staff, will not be concerned about typically what is the Pascal pressure between the rooms. So they will just see if it is green indication, the area is safe to go. If it is red indication, they have to be they have to immediately call the management. So this will also give an audio alarm. So the moment that light turns red, it will start buzzing. So currently what we do is we either measure it the difference and give it to the BMS, or we use this the pressure gauges, right? So what this pressure gauge will do is this will show this kind of indication. This is a very analog and typical indication which cannot be read by the non-technical people. So we cannot expect doctors and nurses on maybe the ward boys to read this kind of reading and give the feedback to the BMS staff. So basically, this is a differential pressure transmitter which can also give you a local alarm indication, and it will also give supply to the BMS. So this is one innovation what we have done for the safety of the patients globally, and it is easily configurable by opening this thing, and you can easily configure it at the hospital itself, right? We will go to a second innovation that we have made. It is one of the products called Cetra Flex, which can monitor up to 18 parameters. I'll just show a small video on that. And basically, before showing the video, we'll just have one small poll, which will, give you what is, what kind of pressure gauges do you use at your facility. I would request everybody, yeah. Okay, 5 more seconds to go. Great. Almost 70% people say that they use differential pressure gauge analog type at their facility, and 30% say they don't use. So, I would request the 30% who don't use a pressure gauge, to typically use digital differential pressure gauge, which can give you a local indication as well as the indication to the BMS. Cetra Light comes with a 0.5% accuracy, which is highly accurate because when it comes to life safety, we need to be accurate. And the conventional pressure gauges are up to 5% accuracy. So which should ideally be not acceptable. Right. So we'll go to one another product called Cetra Flex. Just go through it and let us know.
When stakes are at their highest, trust 50 years of engineering excellence. Trust safe and precise sensing technology, field tested in hospitals, clean rooms, and laboratories across the world. Trust the first choice of facility managers and healthcare engineers who value reliability and peace of mind. Trust the experts who know how to help you keep critical environments safe for everybody. Trust Cetra Flex.
right? So this video shows, what is Cetraflex basically. Cetraflex is a room pressure monitor which can monitor up to 18 parameters of your facility, right? And this works on analog as well as backnet input. So basically, this is how the monitor looks, and this is how all the badges look. So it can take input of any third party device over 4 to 20, 0 to 5, 0 to 10, or over backnet. It can also take inputs from the third party controller. So basically, if you have an existing facility and if you want to intend to keep a common monitoring station at maybe at a nurse call, or maybe a nurse area, or maybe the reception area, you can just keep this unit. You can take inputs from your existing controllers or your existing sensors, and then you can all sorts of permutation combination is possible here, wherein you can change the room name, you can change the profile, you can change this header and everything. So this is one hub which gives in sensor input as a localized display, right? So then we have normal temperature and humidity sensors which can measure the temperature and humidity at the duct level of AHU and at the room level as well, and this can give input to your BMS and the EMS. Right. So what are so as we saw about the pressure monitors, the air change monitors, what Cetra solution can go to your facilities. We have differential pressure transmitters, we have room pressure monitors, we have temperature humidity sensors, we have velocity sensors, we have particle counters, and then we have latest launch air quality monitors, right? So these are the set of products that can you go into your facility. And then this is a unit called Cetra AirWatch. We'll just come to it. Right, so these are certain used cases wherein if this room is a tuberculosis or COVID-19 contaminated room, what would you put inside here? You will put a temperature sensor here, temperature humidity sensor here. You will keep an airflow sensor here, which will measure the airflow basically just to check whether the negative pressure is maintained or not. And then you have a pressure monitor here or a Cetraflex here as a localized display, which will give you the indication of what is the temperature inside the room, what is the humidity inside the room, what is the pressure, what is the air change, everything. So this is one used case of the hospitals, right? This is again similar kind of application that you have. This is an application wherein you have multiple isolation rooms. There is one common empty room for it, and then there is a hallway. So let's say if this is an isolation room, you keep a Cetralite here to check the negative pressure. Similarly here, and similarly at the isolation room 4. And the entire room again has to be negative as compared to the hallway. So the entire room has to be pressurized in a way that it keeps the isolation room negative and it keeps the hallway positive as compared to it. And then we take the entire situation, noticing at the Cetraflex end. So Cetraflex will be a common monitor which will be located just outside of a chunk of the isolation room, and doctor or maybe the nurses can see, or maybe the hospital healthcare facilities managers will see it whether the pressure is maintained or not, and then they will enter the room. Right, again when for an example, if there are areas where there are high risk patients, such as maybe the cancer patient or HIV patient or any patients whose immunity is down, so this area has to be kept under the positive pressure. So it should not happen because this is a non-contagious disease. Cancer, maybe HIV is a non-contagious disease. So this disease cannot spread through the air. So for an example, if you open the door, the air inside the room should move outside, because if the contaminated air from outside will move inside, this will be very much high risk and danger for the patients of maybe high risk patients, maybe if they are highly diabetic, or maybe if they are cancer patients, HIV patients, or any patients, right? So this is one example of the positive rooms. Similarly, the operating rooms, right? So these are certain solutions which you can guide your for your healthcare facilities. For an example, if it is an operating room, you can have one common monitor. You can have a temperature humidity sensor, you can have an air change sensor, and a particle count. For an example, if it is an NT room, you can keep a Cetralite for pressure monitoring. For non-critical spaces, you can just keep a temperature humidity and differential pressure monitor. So these are certain set of examples that we can offer you depending on the type of area. Then we have different kind of differential pressure transmitters which are highly accurate, and this can be used to monitor the difference of pressure at the AHU end and also at the filter end on the HEPA filters and the supply filters. Then we have particle count, different types of particle counters. This is a handheld type particle counter. You can just take it, you can carry it to different operating rooms or maybe different isolation room. You can check the particle count, you can come back, and then you can take the printout of these particle counters, and then you can submit it maybe to the facility managers, whether the area is getting maintained or not. Then you have the online type particle counters, which is for the continuous monitoring, and then you have a highly the CFM of this is 1 CFM, so you have a high pressure inside this particular particle counter. We have got a wide range of wireless temperature and humidity sensors. Basically, the areas where the hospital is already built or the healthcare facility is already there, we have got a wireless solution which can measure temperature, humidity, CO2, and it can wirelessly transmit the data to the software. Right, these are helpful for the areas where the cabling and which is not feasible, and this is battery operated, and again this is IP65 for the rough areas. Right. Then we have the indoor air quality monitor, which is our latest launch, and we'll have the product in a month or two. So again, we talked a lot about sterile preparation areas, maybe the OT areas, after surgery areas, isolation room, but we did not talk about the common areas, maybe the reception areas or maybe the lift areas, the lift lobby and everything. We need to have an air quality monitor for a general monitoring of the guests coming inside your facility. So these monitor will give an instant indication to your mobile and to your web browser. And what we have here is PM 2.5, PM 10, the CO2 level in the facility, what is the temperature, what is the humidity, and the TVOC level. So you might have seen a lot of areas where people are showing the air quality index. So this will give an air quality index of your facility. So again, this is this becomes a selling point for the healthcare and the hospital management, because the area is the quality of the air is really good for the general people sitting inside the room. Right. Then this is a much talked unit called Cetra AirWatch. What this unit will do is, this will suck the air from these vents and it will throw outside. So the hospitals which are already built or the retrofit areas, or maybe the where the important doctors sit, you can just put this unit. This works as an air purifier and the negative pressure generator. But apart from the air purification, what it will do is it will suck the air, and while throwing outside, it has an UVC cleaning inside it. So when the air goes outside, it is 99.99% sterile air. So for an example, you want to create an isolation room inside your hospital. If you want to create a COVID ward, what we'll do is we will just put this unit and it will just throw the air outside, because this is mandatory, as per the NIBH guidelines, that the room has to be negative. So how do you create a negative room? You throw the air outside the area. But while throwing the air, it should not happen that you contaminate the other patients inside the hospitals or maybe outside the corridor. So while throwing outside, it has an UVC and an HEPA filter inside. So this generates in 15 air changes inside your room if the room is 1400 cubic feet, and you can give us the calculation of the room, while you can give us the length, breadth, and height of the room, and then we'll design the system accordingly. This again, graph which shows that before putting Cetra AirWatch, what was the quality of air inside the room, and now what is the quality of the air. So this is what we say. This is a NRTL certified, and it is 99.99% effective in neutralizing the viruses and the bacteria. Right. So this is how it is put. If it is an isolation room, you just put a unit here, you put an exhaust outside, so it will suck the air inside and will throw outside. So the room becomes negative as compared to the positive, and also it sterilizes the air inside. Right. And then we have continuous environmental monitoring software, which is a 21 CFR software, which will monitor the data of all the sensing equipments what we earlier talked about. So basically, this is these are all these field devices. It may be differential pressure transmitters. It will maybe Cetra light, Cetra flex, temperature sensor, humidity sensor, air change sensor, particle count, everything you will measure. You will put some gateways, and then you have a software here which can work on cloud. So you don't need to keep a physical server inside your hospital, which is an additional cost. You can just put the data to the controller, and the controller will throw the data to cloud, and from cloud you can just putting the IP on maybe the the mobile software as well. Right, so we have we are done with the sensing part of the hospitals and the clean room facilities, and then this is a basically a used case where you have people counting, where you have Cetraflex, you have pressure monitors, your door switch, temperature, humidity. So the entire thing goes to the software. So this is how the software looks. Basically, it will show you all the graphs and everything inside the room. Right, we are done with the presentation. We are up for the questions. If you have any questions, you can just type it in the type box, and post that. You can also scan this QR. So this QR will take you to the Cetra's web page, and you can write, put your inquiries there, or whatever inquiries do you have, you can just put there.
Richard, we have some questions in the question box.
Okay, so what it says, just give me a second. Can you just read out the question to me?
Yeah, I'll just read out some of the. So one of the questions is there an e-certificate for the webinar and handouts for the recording of this presentation? If so, please send me. So yes, there is a e-certificate that we'll be getting for this webinar, and it would be coming to you on your email. And we will be also sending the recording of this presentation. Second is all sensors have calibration possible. What is the traceability and calibration is possible or not?
Yes. So yeah, Priyank, you can continue.
So most of the sensors that we have, they come with a calibration certificate, and yes, they can be calibrated, and they are mostly NIST traceable. So you can have the traceability of the calibration. Second one is a slightly complex question. I think so. It is like, dear sir, as per NABH, OT terminal velocity mentioned is 30 to 35 FPM. Previously, it was 90 FPM. How 35 FPM will be maintained laminarity? Till it means for 8 by 6 feet LAF CFM requirement, it 1500 only generates dehumidifier. CFM needs 3000 CFM. Sorry, dehumidifier CFM needs 3000 CFM. How do pump remains at 1500 CFM to the terminal HEPA 13 filter?
I think
maybe we'll take up this question.
Yeah, we'll take up this question personally. So in the interest of time, we'll take this question later. So we have another question saying that please elaborate the principal working of DPS, that is a differential pressure switch. Right. So what I think the questioner is Soumitra Banerjee. So yeah, hi Soumitra. Basically, what DPS does is it will measure the difference of pressure, and unlike differential pressure transmitter or a central light which we showed earlier, it will give an on and off output. For an example, if you put that if the difference of pressure becomes 50 Pascal, it will give you NONC contact. So it will not give you, for an example, even if you place it near the HEPA filters, or maybe the pre-filters or the fine filters, or if you keep it across the room, it will just give you an on and off data. It will not show you the difference of pressure. So it will just take it. We will have a two tubes in that particular DPS. One tube will measure the high pressure and one will measure the low pressure. So that is how it works. Another one is, do you recommend portable dehumidifier, refrigerated type, and steam spray humidifiers for maintaining humidity? Is there any chance of growth of bioburden due to improper drainage? I think, sir, this question is more related to the dehumidifier and the HVAC, part of it. But yes, dehumidifiers can be used, to maintain the humidity inside the room. And as you rightly mentioned, there are the chance of growth of bioorganisms due to improper drainage. But I think this question can be rightly answered answered by the HVAC consultants, or maybe the HVAC vendors.
Then the question is, Ruchir, what kind of doors recommended to maintain the positive and negative pressure? So normally you have this clean room doors for the hospitals. So they also have a proper sealing and framing which is done so that the air leakage does not happen, outside and the inside. And once the proper sealing is there, the air would be maintained once the door is closed. So that will help you to maintain the positive and negative pressure, and there is no air leak that is happening between the air gaps and the joints at the doors.
Correct. Another question is, does Setra AirWatch treat the air before discharge? So the answer is yes. Basically, you have an HEPA filter and a UVC cleaning inside it. So it will clean 99.99% of your viruses and the bacteria before discharging it. So this is basically, how do you calculate air balance in clean critical room? So I think with air balance, what is done is you calculate the supply air, you calculate the volume of the room, and then you calculate the exhaust air. So depending on that, I think this air balancing is done. The pressure balancing is done, using the difference of the pressure, which is to be maintained. So it is basically, more of the supply and the exhaust part.
Yeah.
How do you modulate the supply and the?
You get this air velocity sensors also, so that will help you to determine what the air inflow is, the air velocity meter, and based on the calculation, you can determine what kind of CFM that you are getting.
Yeah, so basically, using the air velocity and the differential pressure, will give the feedback to BMS, and the BMS will accordingly modulate the supply and the return dampers. So that is how the air balancing is done inside the clean room. So this is more of a controls job. Okay.
I guess, Ruchir, we have answered most of the questions. So if you have any more questions, you can scan this QR code and reach out to us on our website.
So I think, yeah, no problem. So we'll connect for the people who are already there here, and we'll send all the so because Priyank, most of the people are asking for some kind of presentation or certificate, so we'll reach out to them.
Yeah. So an automatic email that would be going out to them after this webinar.
Oh, no problem.
So thank you everyone.
Fine.
So you have anything, Ruchir? Say more. You can give the
No. I think we can give the closing comments.
Thank you everyone for joining us for this session, and we hope that we tried to give you more information on how the safe air is created in the healthcare segment, and we hope that this will help you to meet your customers and your requirement also going ahead. And do connect with us for any questions, and if you have any queries or inquiries, do let us know. You can reach out to us on our website, or you can scan this QR code as well. Thank you, everyone.
Thank you, everyone.